Hello, everybody. Let's talk about section 4.5 on our journey through logarithms. We're going to talk about logarithmic properties. So there are a bunch of different formulas here. You do get to use notes on your exam. So like before, just make sure that you know what the formulas are and know how to use them, but you don't necessarily have to have them memorized. So the first is called the product rule. And so if you have a log with two things multiplied inside it, you can split it up into multiple logs and have log base b of m plus log base b of n, where it's m times n. So if we're going to expand this logarithmic expression, what we're going to do for this one is we're going to have this as log base b of 8 plus log base b of k. And that's it. That's all that there is to this particular one. So you're going to split it apart, have a log of the first factor that's being multiplied plus a log of the second factor that's being multiplied. For this next one, this is the quotient rule. So here, if you have log of m divided by log of n, you can split that apart, and this time you're going to subtract the two logs rather than add them. So this is going to be log of m minus log of n. So let's see here. What we have going on with this one, we're going to have log of 3, and we're going to have all the stuff on top, which is 7x squared plus 21x. And then we will subtract each of the factors that are underneath here. So we're going to subtract log base 3 of 7x. We're going to subtract log base 3 of x minus 1. And then we're going to subtract log base 3 of x minus 2. So that is that one. So anything that's in the denominator, anything that's on the bottom is going to be subtracted in its own logarithm. Anything that's going to be in the numerator, anything multiplied, would be added together. The last one is the power rule. So what that one says is if you have log base b of m to the n power, what you would do is you take the power, pull it out to the front, and multiply that number by the logarithm. So you'd have n times log base b of m. So if we were to do that with this problem, we have log base 2 of x to the 5th. We're going to do that as 5 log base 2 of x. That one is now simplified, so the 5 just comes out to the front there. This one, you've got ln of x squared. That's going to be 2 ln of x. That is what that is equivalent to. Here, we're going to use all the properties together. So you've got ln of x to the 4th, y all over 7. So we're going to do this in 2 steps. First, we're going to write them so that each chunk, the x, the y, and the 7, each of those is going to be in its own logarithm. So what we're going to have is we're going to have ln of x to the 4th. We're going to add ln of y because that is being multiplied. The 7, since it's on bottom, that is being divided, which means you will subtract it and have ln of 7 as the final logarithm. At this point, any powers that might still be at play, those numbers you're going to need to remove from inside. You're going to pull them out to the front and multiply them. So then what that would mean is that this is 4 ln of x. The 4 just comes out to the front. And then the rest of this stays the same because the y and the 7 don't have any powers. They're just going to stay as is. And there you go. That is what that would be equivalent to. Here's another one. It's very similar to the last one we did. So again, each individual base, each individual chunk is going to get its own logarithm. So what we would have for this one, we would have log of x squared. That's the first thing. The y cubed is being multiplied. So we would have log of y cubed here, and we would add that. We would add it because those are being multiplied together. The z is being subtracted, so we're going to do minus log of z to the 4th. After we've split them apart so that each one has its own log, any powers that are still there are going to be pulled out to the front, and they will be multiplied by each logarithm here. So what that would give us is 2 log of x plus 3 log of y minus 4 log of z. Okay, so that is the end of that one. Then here we're doing the same process. It's just that here we're going to be doing it in reverse. So now we're going to condense these expressions, and we're going to go from multiple logarithms down to just a single logarithm. So for this one, everything that is added is going to go together on the top. So what that will mean, we're going to have a single log here. The 3 and the 5 are positive. Those ones are being added. So those are going to be multiplied on the top. And then underneath here, the 4 is being subtracted. And the other thing to notice is the 6 is being subtracted. So both the 4 and the 6 are going to end up on the bottom because those are the ones that are being subtracted. We can clean this up a little bit here. 3 divides with 6, and we'll leave you with a 2. So if we were to simplify this, this is going to end up as log, and that will be 5 over 4 times 2, which is 8. So the final answer for this problem will be log of 5/8. So that's condensing, where you're starting with multiple logarithms and then you collapse them down to just one, as opposed to what we were doing earlier, where we had a single logarithm and we were pulling it apart and expanding it. Here is one where we're going to condense. Now, the first thing that I am going to do is there's this 4 out here. And what I'm going to do is distribute that to each of the terms inside here. So let me finish writing this down here. So each and every one of these is going to be multiplied by 4. That's getting multiplied by 4, and then this is going to get multiplied by 4. So if we do that, 4 times 3 is going to give you 12. So this is 12 log x plus 4 log of x plus 5. And then minus, and then there'll be a 4 log of 2x plus 3. Then what's going to happen, each number that's in front is going to get pulled inside and become a power. So we're doing kind of the opposite of what we did last time. When we expand, we break them apart, adding and subtracting, and then pull out the powers. Here, we're going to pull in the powers first, and then combine them based on the adding and subtracting. So what will this be? This is going to be log of x to the 12th power plus log of x plus 5 to the 4th minus log of 2x plus 3 to the 4th. So then the stuff that's added, those are going to be multiplied together on the top. So we're going to do log, we're going to have x to the 12th, and then x plus 5 to the 4th power. And then this one right here is being subtracted. So that would be 2x plus 3 to the 4th power. And there you have it. That is the result we get for that one there. So when you are condensing, you pull the powers in first and then do the part involving the adding and subtracting, which is the opposite of how it works when you're going the other direction. Lastly, I kind of mentioned this earlier, but when you want to evaluate logs that are not base E or base 10, there is a way to do that on a calculator. And the way you can do that is using something known as change of base. And the way it works is that if you have a base of B, you can do that as a log of some other base and do the log of the number inside divided by the log of the base. So you've got two approaches for how you could do this in a calculator. Either one will work. It doesn't necessarily matter which one you choose. But like if you want to do log base B of M, one way you could work that out is do ln of M over ln of B. If you want to do log base B of M, you could also do log M divided by log B. So for instance, if my goal is to do log of, I don't know, 6 of the number, I don't know, 84 or something, then I could work that out by doing ln of 84 divided by ln of 6. And the way I always remembered this is that here the little 6 is on the bottom, so then the 6 goes on the bottom. That's the thing that's in the denominator. And instead of ln, it would also work the same if you did log 84 divided by log of 6. Those would both give you the same answer. One thing I want to emphasize, please take note of the fact that you need to close the parentheses for your logarithms. If you're using like a TI-84 or a TI-83, you want to make sure to close the parentheses if you're going to be using this formula. Because the most common mistake I see that students run into is they don't close off the parentheses, and then what they're doing is they're doing the log of a number divided by a log of a different number, and it's not what they're intending it to be. So for those who are interested, this isn't really a example, but we can work it out. ln 84 divided by ln of 6. I'll go ahead and show you what this looks like here. So that's what I'm talking about. So you'd have ln 84, close the parenthesis. If you don't close the parenthesis, it's going to mess you up. Divided by ln of 6. And if you work that out, that is equal to 2.4729 if you round that off. So that is approximately, let's go back to that is 2.4729. So that is what that's equivalent to. Fun facts. If you do that doing the log key, you will get the same answer. So the log key is right here. So if you do log 84, close the parentheses, divided by log of 6. So there it is using logs instead of ln. But lo and behold, you get the exact same answer. How about that? You will not get the same answer if you do this, log 84 divided by log of 6, and you neglect to close the parentheses, which I've seen students do a lot over the years. We have not closed off the parentheses in the log. So that gives you a completely different number, which is wrong. So consider yourselves warned. Make sure you close the parentheses on the end of your log functions if you're using a calculator like that, because if you neglect to do that, it's going to lead you astray. Okay, so let's see here. So what do we got? So change log 0.5 of 8 to a quotient of natural logs. Okay. So we can do log of 8, or actually they want natural logs, not common logs. So ln of 8, and then divide that by ln of 0.5. Okay. And then we can actually get a calculator and work out what that is. I think all they were going for is just to write it as a quotient, but we'll just go ahead and do the whole thing. So we're going to do ln of 8, close the parentheses, divided by ln of 0.5. So there it is. That's what it would look like. ln of 8 divided by ln of 0.5, close the parentheses. And if you do that, you end up with -3. So there you have it. It turns out that equals -3. How about that? There you go. -3 is what that is. Evaluate that. So here we would want to do, we have log base 5 of 100. So we would do log of 100 divided by log of 5. Let's see what this is, shall we? Log 100, close the parentheses, log of 5, close the parentheses. There it is. And you do that, you end up with 2.8613, or 14 if you round it off. So that is approximately 2.8614. And definitely make sure you know how your technology works so that you can duplicate these results. You do not want to go in cold and then find that on the test you don't know how to do it with the piece of hardware that you're using. That would not be good. All right, that is the end of section 4.5.